Okay, so we're going to still talk about variables here, and we're going to build on what we have started with this. So far you've learned about why we use letters and how to plug in values for that letter. And that can change from problem to problem. So I could have, and you could even, you could have x plus 8, and put in a 7 for x and you get 15, or you could put in a 3 for x and get 11. So you can plug in different values depending on what x is, and that expression right there stays the same. So that's kind of as far as we went with this. There's a couple things that I want to put down, so a couple rules that will always be true as we go forward so that you can get in the practice of using them. One of them is that if you have a single x or a single g or a single m, whatever letter you're using, you just put that letter. Okay, you don't put 1x. Now, I'm not going to count you wrong if for a little while you do that. As you get used to it, you're not wrong. There's 1x. But if I told someone to come in without even knowing about math and said, hey, can you write 1x up on the board, just write one of them, they would just walk up and do that. They wouldn't put a 1x, they'd just put an x. Or if I said, hey, can you walk up there and just put a single y, one y on the board, they just put a y. So when it's 1, you just put 1. Now if there's 2 x's, or 3 x's or 5 x's, then you're gonna put like 5x, okay? So I just want to lay that out, that if there's just a single x, you are going to write just x. If you got to write multiple. So an example of that you're going to see in problems is, you may see x plus x plus x, okay? And so they want you to add those together. Well, there's a single x. That 1 is invisible. We've talked about that before in math lab, that there's a lot of invisible things. We even did it here when we talked about the negatives. If you've got a letter or number 8, there's an invisible decimal there. There's an invisible fraction there. There's an invisible positive sign here. It's a positive 8. So in this case, the invisible thing is the 1. There's 1x there. And if you say, okay, so there's 1x plus another x plus another x, how many x's do I have? 3x. I have 3 x's, okay? So that's one rule that we need to lay out. If you see a single letter, the coefficient there is a 1, okay? So that kind of plays. Same thing if you see like a negative version of that. So let's say you see a negative y. Well, that means there's a negative 1y, okay? So it's negative 1. So, same thing if you do this in reverse and say, okay, a negative y and a negative y and a negative y becomes negative 3y. Okay, you just add negative 1, negative 1, negative 1, which makes negative 3, negative 3y. Okay, so that's a quick example of when you don't see a number before the letter, that means that it's a 1. And you want to get out of the practice of putting a 1 there so that you don't, it's not the correct, exact way to write those. Now, if I see it, I'm not going to, like I said, I'm not going to count you wrong. I will remind you, hopefully just kind of be like, hey, don't put the 1s there. You don't need them. It's repetition where you don't need it, okay? So that's one of the rules that I want to lay out. Another rule, okay, and we kind of hit on this when I did exponents with you, okay, and I told you that we would get to that part of it later, but that was the thing where I said like x to the 3 times x to the 4th, and then we also did some number ones like that. We did 3 squared times 3 to the 4th or something. Okay, we did these, and I told you, okay, when you do that, you keep the base the same, and you add the exponents. So it was 3 to the 6. And this was x to the 7th. Okay? And all we learned was, when we did exponents, is I just basically told you to keep the base the same and add the exponents. Well, and that's all we did then. And I told you later it would make more sense. Well, now's the time to kind of put that all together and say, well, this one is easy to see. We could see that this means 3 times 3 times 3 times 3 times 3 times 3. Okay, that's 3 to the 4th, that's 3 squared. So that ends up being 1, 2, 3, 4, 5, 6. That's why we get 3 to the 6th. The shortcut is to just add the exponents. Well, it's the same concept, and I'll leave this up here. It's the same concept here, except instead of a number, we're doing it with x. So we have x times x times x. Okay, that's x cubed. And remember, when you're doing an exponent, it's just whatever the base is times itself. So it's x times x times x times x times x times x times x. That's x to the 4th. And so there's a total of 1, 2, 3, 4, 5, 6, 7, x to the 7th. Okay. Now, here's why that is, whoa. I'd be walking around all day with a green mark on my shirt if that would happen. That would have been disastrous. So, going back to this here, what that means as far as now that we're understanding what we're doing with letters or why are we using letters, that means I can plug in anything for x and it be true and it would be what this lays out. So let's say our original problem of x3 times x to the 4th, okay, and let's say I said, okay, x is going to be 2. Okay, 2 is going to be plugged in for x. Well, we plug it in. Every time we see x, we plug in that 2. This becomes a problem we've done. It's 2 to the 7th, which is 2 times 2 times 2, 7 times. Okay, so that is what that means as far as it does have a purpose. It's going to be this. It's going to be that we need to know when you multiply these, you just add the exponents. Now, when's that going to come up here in our problems? Well, let me give you 2 examples of problems that you'd see that this is going to start to come up. So let's say I have 3x plus 2x, okay? And let's do y. Let's say I have y times, let's just do y plus 4, okay? Actually, sorry, and you won't have to erase anything. Let's do y cubed plus 4, okay? So, and since we're adding in things, just for this example, I'm going to add in a square here, okay? So that, when I do this first one, then we'll do some others that are a little bit harder. So here we've got 3x plus 2x. Here we got the y's. And I want to show you the difference. Here, we're just adding, right? There's just an addition sign. There's no multiplication. The only multiplication going on is right here, but we don't know what x is yet. Okay, they've not told us. They've not said x is 4. If they tell us x is 4, then we could work that problem. We could put in 4, get 3 times 4 is 12. Remember, that's not 34. That's 3 times 4, which is 12, plus 2 times 4, which is 8, and 12 plus 8 is 20. You could solve it. But if they don't tell you what x is, okay, meaning, we don't know what to plug in there yet. It could be 4 one time, it could be -2 another time. We don't know what to plug in yet. We still have to, you're going to see some problems say simplify, meaning make this as small as possible, add in together what you can, and then when you get x, it's been simplified. It makes it easier. Now, at first, it won't seem easier because you're just learning how to do this, and you think, well, why do all that work? But as you get better at it and as you learn it, that's how math progresses, is it does make it simpler than to plug in. Right now, if I have to plug something in, I have to do I have to plug it in here and plug it in here. This is going to simplify it down as best as we can. So if I have 3 x's, and let's just think about holding an x, okay? And an x is a thing, and you've got 3 of them. You got 3 of them in your hand. And then someone comes along and gives you 2 more of them. Okay, so you have 3 x's, and now someone comes along and gives you 2 more x's. how many x's do you have? Well, you would have 5 of those x's. Okay, so all I didn't do anything with the exponents. In fact, there is no exponents. There is one that's, anything that's like there is to the first power. So, but I didn't add those. I didn't add the 1 and the 1 here. I just added the 3 and the 2, the coefficients, to say I have 5 x's. Because I had 3 of them, and then I added 2 more of them. This one is different, okay? This one, we can't add these 2 things. Remember, this is what I was talking about in distribution. It's like all those prior lessons now are coming to this lesson. I told you, what happens when you can't combine these in here. When we did distribution, we did numbers that we could combine. We can't combine these. Here's why. I don't know what this is yet. So it's not a number, it's a value. I mean, it's gonna be something, but we don't know what it is yet. So I can't just add it to a number. Now the videos that you watched Thursday, or prior, talked about this being called a constant, okay? That's the opposite of variable. Variable can change, constant never changes. A 4 is a 4, okay? There's nothing to change there. There's no letter there. It's a 4. It's what we know in the universe is a 4. So I can't add a constant with a variable because I don't know what that variable is, okay? This is multiplying, so I can do that. But when you go to add them, I can't do. So I can't add these 2 things together. So I can't just, if I'm working PEMDAS, I can't just add the parentheses together. So what I have to do then is say, okay, distribution tells me though I can multiply this times this and this times this, just like we did with distribution with numbers. Okay, and just give you a quick review of that. Remember this was on your last test, and I said, okay, that's 2 times 4, which is 8, 2 times -2, which is -4, and 4. And you guys did pretty good on that. I had a really good, most everybody did really well on this part of the test. And you guys did it as distribution. So you were learning that process of this times this, and this times this, and then combining it. The problem is, and I told you the shortcut is I could say, well, 4 minus 2 is 2, 2 times 2 is 4. You can't do that here. I can't combine those like I can combine these. So we're stuck having to do distribution. So just to lay out what this problem is, and I'll do this in red, so it's like, whoa, did he get it wrong? Okay, so this becomes y squared times y to the 3rd, okay? And then this becomes, you're gonna add in y squared times a +4, or you could just keep that plus there. We'll come to that here in a second. So first let's look at this. This is what I was just saying with exponents. When you multiply them, you're gonna get y to the 5th. You're gonna add these exponents because you're multiplying it. So that's y to the 5th, okay? Actually, I started to circle it, but we're not done. And then this is not an addition, it's a multiplication, which you can simplify, you can do. And if you've got a y squared, okay, and you've got 4 of them, you're multiplying them times 4, that means you have a +4y squared, okay? There's 4 of those y squareds, and you just switch places and put that there, because that's how you would write it out if you had 4 yo-yos. You'd put the 4 first, 4 y squares, okay? Now, we'll get more practice with this, and I know this is like, whoa, this is like 10 things at once, and that's the sound you make when that happens, like, whoa. But basically, I wanted to show that, hey, there's all these things that we've been alluding to, all these things we've been talking about that we're going to get to that start to come to play here, start to happen. Okay, so those are some of the rules going forward that we're going to, and I'm going to keep repeating them, but I wanted to lay them out to show the differences and when you're going to start to see that. Now, the first problems we need to look at that we're doing with this, because all the problems you've done so far are just called substitution. You're just substituting in a value. And if you notice, those ones I had you do a couple lessons ago, they had no equal sign. So like I had, x plus 5, and then I said x is 7. Okay, that meaning the equal sign's there, but in this problem I just had you plug it in and the answer was 12. Okay, that's because they were telling you what x is, and those are the first little problems we did. Well, now we're going to do these things called equations. We're going to start off very, very simple, and then I'll kind of end this video and we'll keep working as we go forward. Okay, and I've used this word before in that first lesson. Equations means that there's an equal sign in the problem. Okay, so here's an example of an equation. X plus 7 equals 15. Okay, x plus 7 equals 15. This is an equation because it has an equal sign. Okay, and we're not going to be told what x is, or y, or g, or l. That's substitution, and we've already kind of done that, and that really don't take, that's why I only did 1 day on that, because, we can, I think that's pretty quickly, we can just learn to plug in something and solve the problem. What our problem is going to be is we have to solve for what x is. So instead of them telling us what x is and us plugging it in, we have to now find out, well, what does x got to be to make this a true statement? Okay, so we can't just pick random numbers. If I pick 3 plus 7 is not 15. Okay, and so, it's going to mean one thing. Now, every once in a while, there can be more than one answer, and we'll get to that later. But in this example there's only one thing that I could plug in here to make this true. Okay, and so that's what we're working with to start here, is solving for what the letter is from an equation. Okay, so this one we could probably look at and solve, and probably you've already done that by now and figured out what number would go here. But with math, we know that they get harder, and so we need a process, kind of like when we did integers with negative numbers. And at first, we could do them on the number line and we could solve them that way, but then they got so big we couldn't use the number line anymore. Well, that's the case with this. We're going to start with simple ones that we could probably solve in our head, but it's good to learn the process from these, okay? So here's this first little lesson with this, okay? And let me check my time on this because I don't want to go so long. Okay, yeah, we're doing. So basically, what we're going to do with this is we need to solve for what x is, and so there's going to be a process for that. Now, here's how, there's several ways that you could learn this. In fact, there'll probably be some other ways I may show you on other videos. To give you just examples, I'm a teacher, you know me, I've always, if you've had me in class, I'm not necessarily concerned with you doing it my way. I just want to make sure you're getting them correctly. So if you've got a different way that you've kind of learned on some of this and you're like, hey, it works for me and it comes out right, I'm good with that. The problem comes with if you're missing them all, then I would be like, hey, why don't you try it this way? Now, you're also going to see that as I teach this, I'm going to show you some things that I don't always do. I definitely don't do when I'm doing the problems on my own and just solving them for myself, because I've already learned these and it's become second nature and I don't necessarily need to do them. But I'm going to try to be very careful to always try to do them at first so that you can get in the habit of seeing that, okay? One of the things I'm going to do is we're going to create a fence, okay? We're going to create one side of the problem and another side, okay? And so to do that, I'm going to find a dividing line. It's not going to be in the middle, okay? Where it's going to be is this equal sign. We're going to have something on this side and something on this side, okay? So to do that, I'm just going to draw a line. And you don't, like I said, you do it real faint. Hopefully you're doing these in pencil so that you can, later if you need to, erase that or kind of see it better. But we're creating a fence here. And it helps me visually to do that at first because I can kind of see, otherwise you kind of lose track of where the fence is, or you lose track where you're working. Okay, so I've created this fence here, right where the equal sign is. Okay, and then I've said, okay, now I want on one side of the fence, and I've taught this in different ways actually, even when I first started here. Technically, it does not matter which side the variable's on. You could have the variable on the left side or the right side. But I learned over time that students really struggle with choosing, okay? Especially when they're learning it at first. I have a lot of students that just worry about picking the wrong side, or they get kind of lost with, once just making that decision. So I try to take that out of it. And so from that, I kind of built where I like to just teach it at first, where we're going to put the variable on the left side, okay? We're going to have the variable over here so that when we're done, we can say x equals this, or y equals this, okay? So it just kind of gets us in the practice of saying it that way and having it that way. Plus, you're going to find out as you learn it at first, that takes that part of the problem out. It takes that having to choose which side. Now, just know as we get further, and like I said myself, I don't always do that, because now I know, hey, it doesn't matter which side that the variable's on. But for now, we're going to always make sure the variable's on the left side. Good thing about this problem, it's already over here. It's already over on the left side, okay? So just so you see, here's the left side, there's the right side, the variable's already over here. Okay, remember the variable is the letter. It's over on the left side. So that's what we're going to work towards. It's already over there. The next thing we're going to do is, and this is a actual, you can look up videos on this. It's isolate the variable. We're going to isolate the variable. That word isolate we've become very, very familiar with these last few months. I'm sure you've heard it outside math. You isolate yourself, you get away from everybody, you're by yourself, okay? And so that's exactly what it means. We're going to make the variable be completely by itself, okay? And I'll refrain from making too many jokes of our current situation, but basically we want this over here by itself isolated, okay? So that means in this problem, we've got this constant here that needs to be somewhere else, okay? It needs to be on the other side of the fence, okay? It needs to go over there because we want to isolate this variable. Now, that's the first key, is realizing what all needs to go where. This is on the left side already. This needs moved, this plus 7, because all we want left is x, okay? So how would you move this over here? That's going to be the problem at first. Is how, those first little bits you're going to get, but then you're like, okay, how do I move this over here? Okay, and that's going to be the main part of this first problem. Now think about if you've got an equal sign. And let's say I said, and I know I'm jumping around a little bit, but this is kind of how you have to work this in. I really try to explain why we do this. But let's say I have 9 equals 9. That's a true statement, right? 9 equals 9. We all agree on that? I probably have to use a different color because it's kind of faint there. But 9 equals 9. And we all agree that that's true, okay? 10 doesn't equal 9. 20 doesn't equal 9. 9 equals 9. Now let's say I was to just take a random number away from it or add it, doesn't matter, but let's say I say, okay, I'm gonna take away 3, okay? And remember, this is a fence, okay? And so if I took away 3, okay, what would I need to do to this side to get this to still be true? Okay, to still have this be a true statement. Can't be 9 anymore, 6 doesn't equal 9. What I would have to do is take away the same thing. Okay, that's the only way it's going to be true, is to take away the same thing I took away from this. Okay, so that's what, if I do something to this side of the equal sign, the fence, I got to do the same thing over here for this to still be a true statement. Okay, I think we're all probably in agreement there. If you disagree, let me know and we can talk about it. But that's how you could get one side being the other. Well, what if I was trying to totally get rid of that 9? Let's say I was trying to get rid of it. Well, what is the only number that means nothing? That means you've gotten rid of it, there's nothing there. That's 0, okay? So I want to make this a 0. What's the only way that I can make a positive 9? Okay, that's the key on this one, it's a positive 9. How can I get that to become 0? What would I need to take away from that 9 to get it down to 0? Well, I'd have to take away 9, okay? And if I do that over here, then the only thing that's going to keep this true is over here, okay, is to do the same thing over here, okay? Now, that's if you're working with a number and a number. The problem is over there, you know, we've got this number, and these aren't the same numbers, but we've got this variable. It can be anything, okay? But this concept is still true. If I take something away from over here, then as long as I take away the same thing over here, then it's true. It's going to come out the same. And so, you know, let's say, and it's the same thing with addition. Let's say I had a -3 equals a -3, okay, and I've got my fence here. Well, I want to get this to 0, so instead of taking away, I'm going to add 3, and that's going to make it 0. But if I add 3, then I need to add 3 over here, which keeps it the same, okay? I have to balance that out. If I do something over here to get it to there, I have to do the same thing over here. Now we take that concept and move to this problem. I want this to disappear, this +7. Now, what's a little bit different is we've got a variable, so what happens is these two numbers don't have to be the same anymore. Okay, but as long as I take away the same thing on both sides, I keep everything in balance. So let's do that and see what happens. Now, if you've already solved this in your head, you probably already know it should come out as 8, right? 8's the only thing that we're going to put there to make this a true statement. So let's do this process and see if it comes out that way. I'm going to take away a 7 to get that to 0. Okay? If I take away 7 on this side of the fence, I'm going to take away 7 on this side. And I end up, these come out to nothing. That 0 we don't need to put. It's like the repetition. We don't need nothing when it's not needed. So it cancels out, and I'm left with x. I'm left with this still. I've still got my equal sign, my fence. And now over here, I'm going to do 15 minus 7, and we get 8. We get the answer that we were looking for, the only thing we could plug in to make this true. Okay, let's do that again. Different problem. Let's do y plus 12 equals 37. Okay, this one's a little bit bigger, and we think, oh, right away, I don't know what it'd be, but if we thought about it long enough, you could probably already figure out it should come out as 25, right? 25 is the only thing we can add to 12 to get 37. But it didn't probably come as quick as that. So, but let's use our process and see if it's true. We want this to become 0. We want to isolate the variable, the y, doesn't matter what letter it is. So we need to get rid of this positive 12. So we need to subtract 12. And if we do that on this side of the fence, we need to do it on this side. Those cancel out. 12 minus 12 is 0. We're left with the y equals, that equals don't go away. 37 minus 12 is 25. Okay? And that's where, you know, I don't always draw, I definitely don't when I'm doing the problems myself, draw that line, but I think it helps at first to see that fence, to know that you're working with two sides of the problems, okay? Let's do another one, except this one I'm gonna change it up just a little bit. Okay, g minus 4 equals 8. Okay, g minus 4 equals 8. Now, just looking at this problem real quick, what do you think it is? I've heard some people, you know, probably something like that, say 4. You know, they think, okay, if I take away 4. But if I plugged in 4 for this, 4 minus 4 is 0, not 8. So that's the first tricky thing in you know, kind of looking at it. So let's see what it is, okay? So let's do our fence and say, okay, this case, you know, these were pluses, and now we've got this minus, okay? We've got this minus here. So what do I need to do to get this to 0? And we need to add 4. Okay, negative 4 plus 4 gets me to 0. If you do that on this side of the fence, you need to add 4 over here. Okay, these cancel out. Negative 4 plus 4 is 0. And you're left with g equals 12. Okay, and how you can always check these is plug it back in. Plug it into your original problem and see if that's a true statement. That's why we did substitution first. If I plug that in for G, if G does equal 12, this should be true. 12 minus 4 is 8, and that's a true statement. Okay, so that's doing those. That's where we're going to stop for today. Now I'm going to give you some problems to do for your assignment, but we'll keep building on this. But I want to give you a chance. We've kind of talked for a little while now and covered a few things here. So I'm just going to have you work these problems first. Make sure we got a good grasp of this, and then we'll move on a little bit. Okay. So let me put some equations here, small ones. And you're going to solve for what the letter is, okay? And you're going to put it on the left side. We'll work with what happens when it's on the right side later. But let's do this. X plus 8 equals 17. Y plus, let's go big a little bit. Let's go 35 equals 84. Okay, don't freak out. It's the same process, nothing changed, just a little bit bigger numbers. Okay, let's do x minus 22 equals 36. Let's do v minus 13 equals -4. Okay, I know we've got a lot of negatives there, but remember, you add 13, then see what happens, okay? Let's do m minus 10 equals, let's see, 8. And let's do x plus 7 equals 4. And y plus 9 equals -2. Okay, so little challenging ones there at the end. Give those a shot and see what you come up with, and we'll build from there.